In the last lecture, we were talking about classification of the system, and we discussed about homogeneity as well as additivity. And today we are going to start with linearity of the system. Okay, so we will be starting with linearity, linear system. Okay, so a system is said to be linear. System is said to be linear if it follows the law of superposition. The law of superposition. Okay, and in simplest word, superposition means, so superposition basically means that it's two laws at the same time. So the first law is additivity, and the second is homogeneity or scalability, you can call it. Okay, so if both of these laws are satisfied, then we can say that the system is linear. Okay, and it's a very special kind of system, and we want all of our system to be linear. Okay, so it's very important that uh, one is able to understand whether a system is linear or not. Okay, so how are we going to check? We will check whether the system is additive or not. So we will start with the very first one. So in a simplest word, uh, if I have to test it, how I am going to test? Okay, I will assume that if x1 t is the input of the system, so let me just denote t with the system, and because of x1 t, or let's say your output is y1 t, and due to x2t, when the x2t is the input of the system, your output is, let's say, y2t, then principle of superposition says superposition says that for uh, constant k1 and k2, where k1 k2 can be both complex as well as real and complex, can be either real or can be complex, it doesn't really matter. Then for k1 and k2, k1 x1t, k2 x2t must gives the output k1 y1t plus k2 y2 of t. Okay, so this is what we have to test. Okay, so let's start with some of the very simplest problems, and then we will move on from there. Okay, so the very first example that I am going to take is very ordinary system where output is directly equal to your input only xt. Tell me whether this system is linear or not.
Yes, sir, it is linear system.
So it's going to follow both additivity as well as scalability, isn't it? So this is going to be linear.
Yes, sir.
Okay, so
Excuse me, sir.
बोलिए.
Sir, will you please explain again that what is linear system?
A system is linear if it is following what is known as principle of superposition, and principle of superposition means additivity as well as homogeneity. So additivity you already I have already discussed this, and homogeneity as well I have discussed it. So if you combine both of these two, then it's going to be superposition, and that can be given by this statement only. This statement here, that if x1t if y1t is output due to x1t and y2t is output due to x2t, then if you give the combination k1 x1t plus k2 x2t to the system, your output must be equal to k1 y1t plus k2 y2t. Okay, this is what this principle of superposition says. Is this clear to you, or do I have to explain it a bit more?
Yes, sir. Yes. Clear, sir.
And you have already seen superposition theorem there in uh, network theory as well, so it doesn't tell me. So this system is linear actually. Okay. So this is a linear system, and we can easily verify it. So the way you can verify it is that let x1t be input, then what is going to be your output? I will assume that to be y1t, and y1t will be equal to x1t only, isn't it? Because this system says that output is equal to input. So x1t is input. So if I am saying that my output is y1t, then that must be equal to x1t. Similarly, if I give x2t as input to the system, okay, what is going to be our output? Let's assume this to be y2t and this is going to be x2t, isn't it? Output is equal to input only. So if I apply k1 x1t plus k2 x2t, this must give me, let's say that output here in this case is going to be y dash t, then y dash t is going to be equal to your input only. And what is input? K1 x1t plus K2 x2t. Sorry, K1 x1t plus K2 x2t. And from these two equations you can see that x1t is nothing but y1t, isn't it? So K1 y1t plus K2 y2 of t. So you can see that K1 x1t plus K2 x2t is producing K1 y1t plus K2 y2t. One pictorial way of seeing this is, I mean, I'm not going into, it doesn't really matter, it's the same thing. Okay, what I'm doing here in this signal flow diagram type. Okay, so let me give you another problem. And um, so the idea here is not just to identify whether the system is linear or not. Okay, we have to understand the patterns that are there. Okay, so let me give you another problem now. Okay, so next problem is that yt output is equal to input xt times x of t minus, let's say, 2. Okay, this is another example of a system. Now tell me whether this system is linear or not. Or before going into that, let me just ask you this. Uh, uh, Let me give you this problem. Yt is equal to uh, x of t minus 2. Okay, so output is shifted version of input here. What is this system? What this system is doing? You have to understand your system first from the input output relationship. So ये system क्या कर रहा है, कोई बताएगा मुझे? Can anyone tell me what this system is doing?
Sir, it advances the signal.
Or delays the system, delays the signal. Delay कर रहा है, advance कर रहा है?
Delays.
Yes, yes, sir, delay.
Delay.
Delay. It's introducing delay, right? So हम बेसिकली क्या है, हम xt इनपुट दे रहे हैं और हमारा आउटपुट क्या मिल रहा है, x of t minus 2, delayed version of the input only, isn't it? So tell me whether the system will be linear or not.
Yes, guys, it's like a buffer, right? It's keeping the data, then after some times it's providing the data. So the buffer will behave like a linear system or not? It should or it should not. We see this right in digital electronics that D flip flop, they just provide the delay.
Okay, but we have to check it. So let's just do that. Let's assume that x1t is the input. Okay, and due to x1t, what is going to be our output? Output is, let's assume that to be y1t. Y1t is just a symbol that I am assuming. Okay, and what will be the y1t equal to based on this system? x1t input है तो output क्या होगा आपका? x1 of t minus 2, isn't it? Is this clear? Similarly, if x2t is the input to the system, okay, what is going to be your output? Y2t, let me assume this, and y2t will be equal to x2 of t minus 2, isn't it? This is what we will be getting. Am I clear or not? So let's say if
Yes, sir.
I will give this system input a1 x1t, where a1 is just a constant, plus a2 x2t, and I mean I'm going to, मैं इसको अंडर ब्रैकेट एक्स डैश टी लिख देता हूँ, ठीक है, so that it will be easier for me to write down what is my output is going to be. So sorry, so this is the system, and let me assume that output is y dash t. So y dash t will be equal to what? X dash of t minus 2, isn't it? But what is x dash t? Is a1 x1 t plus a2 x2t, isn't it? And x dash t minus 2 क्या होगा? t की जगह t minus 2 लिख देना है. So this will be equal to what? a1 x1 t minus 2 plus a2 x2 of t minus 2, isn't it? This is what we will be getting. Am I right or wrong? So this will be in term equal to a1 y1 of t. Y1 of t is what? X1 t minus 2 plus a2 of y2 of t, that is y2t is equal to x2t minus 2. So you can see that a1 x1t plus a2 x2t is producing what? a1 y1t plus a2 y2t. So this system is linear, isn't it? Is this clear? Is it clear to all of you? Okay, now based
Yes, sir.
based on this example, what can we conclude? इस एग्जाम्पल के आधार पे हमारा कंक्लूजन क्या होगा? डिले एंड एडवांस doesn't make the system non-linear. यानी हम अगर सिस्टम अगर एडवांस कर रहा है इनपुट को या डिले कर रहा है इनपुट को, तो उसकी वजह से वो नॉन लीनियर सिस्टम नहीं होगा. इज दिस क्लियर टू एवरीवन? So this should be our conclusion. Whenever we are solving problem, our aim is not to get, I mean, of course we want to know whether the system is linear or not, but at the same time we also want to learn कि we want to abstract it, okay, so that we can apply everywhere. Is this clear to everyone? Is it clear? So this is going to be our conclusion. Let me again highlight this. Okay, delay and advance doesn't make the system non-linear. If the system is linear, then it's going to be linear. Okay, delay और advance से कोई फर्क नहीं पड़ता. Next question is, yes, बोलिए.
अरे जो ये प्रीवियस क्वेश्चन जो था वो डिले कैसे एक्सप्रेस कर रहा है वो एक बार समझाएंगे, क्योंकि मतलब जो इनपुट वैल्यू t पे आ रही है वो आउटपुट
हाँ
में t-2 पे हमें मिल रही है। इसका मतलब
हाँ
एडवांसमेंट मतलब एडवांस होना चाहिए ना, उधर एडवांस एक्सप्रेशन होना चाहिए ना।
ये क्या
यस यस वही एग्जांपल सर, y of t is equal to x of t-2।
x of t minus 2, एक मिनट, you draw this, okay, let's say आपका ut है, ut will be like this at t equal to 0 से, this is ut isn't it, u of t minus 2 क्या होगा, कहां से चालू होगा, u of t minus 2 कहां से होगा, यहां से चालू होगा,
यस सर 2 से।
somewhere here t equal to 2 से,
यस
t equal to 2 से। अब मुझे बताओ जो 0 पे आने वाला सिस्टम है वो 2 पे आ रहा है, तो ये एडवांस हुआ कि डिले है, 12 बजे जो ट्रेन आने वाली थी वो 2 बजे आई, तो वो सिस्टम को क्या बोलोगे तुम,
लेट आ रही,
ट्रेन एडवांस हुआ कि डिले हुआ? क्या हुआ,
लेट, डिले डिले।
डिले हुआ ना, तो मेरा ये एडवांस हुआ कि डिले हुआ ये बताओ,
ये सर डिले।
अच्छा वो कंफ्यूज
अरे
इसलिए हो रहा है क्योंकि यहाँ पे t लिखा है yt में और x t-2 में t-2 लिखा हुआ है, तो इज फीलिंग लाइक वी आर एडवांस हो रहे हैं।
हाँ, नहीं देखो जब भी कंफ्यूजन होगा ut माइनस 2 और ut प्लस 2 प्लॉट कर लो और फिर अंदाजा लगाओ कि 12 बजे ट्रेन आने वाली है, अगर वो 12:30 बजे आती है तो डिले हुआ कि एडवांस हुआ, ठीक है, और अगर 12 बजे आने वाली ट्रेन 11:30 बजे आती है तो वो डिले हुआ कि एडवांस हुआ, सो इट इज बेस्ड ऑन दैट लॉजिक, ओके, इट्स बेस्ड ऑन सिग्नल्स लॉजिक, इज दैट क्लियर?
यस सर यस।
ओके मैंने अब मैं भी कई बार कंफ्यूज होता हूँ, तुमने क्वेश्चन पूछा तो मैं भी कंफ्यूज हो गया था, आर यू गेटिंग माय पॉइंट? So I always forget it. Then I again draw this function and I remember, okay, this is delay. I mean, it's kind of built in now, but वो हो जाता है. So it's not a big deal. Okay. Now the next problem that I am going to take is our output here is given as x of 2t. Okay. Now tell me whether this system will be linear or not. ये नॉन लीनियर है or is it linear? Okay, let's check this again. Uh, let's say x1t is input to the system. Let me do this in different color. Black. Let's x1t is the input of the system, and because of x1t, our output is, let's assume that to be y1t. Okay, then what will be y1t equal to? It will be x1 of 2t, isn't it? Similarly, if h2t is the input to the system, what is going to be the output? let's assume that to be y2t, and y2t will be equal to x2 of 2 times t, isn't it? This is from the given from the problem only. Now next we will like to give system input as a1 x1 t plus a2 x2 t, and assume let's assume that this is x dash of t. Okay, then if we give this input to the system, then let me assume that output is y dash of t, and what is y dash of t is going to be, it will be x dash of 2t, and x dash of 2t कैसे निकल रहा है, x dash t से, t की जगह हमने 2t put किया, right? So it means this is going to be what, a1 x1 of 2t plus a2 x2 of 2t. Okay, and x1 of 2t is basically y1t, isn't it? So this will be a1 y1t plus a2 y2 of t. So a1 x1t plus a2 x2t is producing a1 y1t plus a2 y2t, isn't it? It means system is linear or non-linear. So system is linear, right? Again, our what is something that we are going to understand from this? You see that even scaling time में कोई भी ऑपरेशन किया हमने, यहाँ डिले किया, एडवांस किया तो भी लीनियर था, स्केल किया तो भी लीनियर था. So any operation on time is not going to affect the linearity. Is that clear? So if the system is initially linear, for example, yt is equal to xt is linear, right? So x of 2t is also going to be linear. X of t minus 3 is also going to be linear. Is that clear to all of you?
Yes, sir.
Okay. Okay, so next problem that I'm going to give you is again a very good problem, that output yt is equal to x of t plus x of 2t plus x of t रहने दो, इतना ही रहने दो, x of, let me just put these two only, x of t plus x of 2t. This is the system. Tell me whether this system will be linear or not. So y2 is equal to xt was linear or not?
Linear, sir.
Okay. Yt is equal to x of 2t is also linear. So now we are adding two systems, both of them were linear. Okay. तो उनको ऐड करने पे सिस्टम हमारा नॉन लीनियर रहेगा कि लीनियर होगा, दैट इज द क्वेश्चन.
Non-linear.
It will become non-linear. Have you solved it? कि ऐसा ही बता रहा है.
क्वेश्चन ऐसा है कि when you add two linear system, the addition will be linear only, or it will change to non-linear, right? You just need to think on this, right? Because you may get questions like this, and the answer should be generalized one. When I add two linear system, will I get a linear system or not?
किसी का आंसर आया?
So non-linear.
Non-linear. Okay, let's check that. Okay. So let's say x1t is the input. Then what is going to be output? Let's assume that to be y1t. And what is y1t will be equal to? Is input x1t times x1 2t. Sorry, plus x1 2t, isn't it? This is what going to be your output y1t. If you give x2t as input, similarly to the system, your output, let's assume that to be y2t, and this is going to be x2t plus x2 2 times t, isn't it? So this is what you will be getting here. Okay. Now if I give system a1 x1t plus a2 x2 of t, okay, then what is going to be my output? Let's say that is y dash of t, and y dash of t is going to be, let me assume that this function here is equal to x dash of t, then y dash t is going to be x dash t plus x dash of 2t. And what is x dash t? Is a1 x1 t plus a2 x2 t. So let me write this a1 x1 t plus a2 x2 t and plus x dash of 2t. So this means a1 x1 dash 2t x1t, sorry, x1 2t plus a2 x2 of 2t. If I take a1 common, what I am going to get? x1t plus x1 2t. Similarly, if I take a2 common, what I will be getting? x1 x2t plus x2 of 2t, isn't it? Right? So you can clearly see that this is equal to a1 y1 of t, and this is equal to a2 y2 of t. So a1 x1t is producing a1 x y1t plus a2 y2t, isn't it? So this system is linear. So system क्या है? Linear. So if you add two linear system, if we add two linear system, two or more linear system, the resultant system is going to be linear only. And it's not about adding. I'm saying add, but what I mean is linear combination. If you take linear combination of two linear system, linear combination, let me write, and आप लोग को शायद पता ही होगा linear combination के बारे में. Linear combination means you can multiply with constant term, okay, and add them. So that is also going to be linear only. So this is something that you have to keep in mind. Is that clear to all of you? Is this clear or not? सबको समझ में आया ये?
Yes, sir.
Yes.
Yes, sir.
So let's move on to the next problem, and that is, let's say yt is equal to, let's say, xt into x of t minus 2. Tell me whether this system will be linear or not. Yt is equal to xt is linear, yt is equal to x of t minus 2 is also linear, right? Now we have multiplied these two. Okay, tell me whether the system will be linear or not. Or the other way you can think of it, that xt yt equal to xt is the system and you are multiplying this with the unknown signal. X of t minus 2 is just an unknown signal. Okay, so एक लीनियर सिस्टम में आपने अननोन सिग्नल से मल्टीप्लाई किया तो आपका क्या रिजल्ट रहेगा. Okay, just tell me about that, whether the system will be linear or not.
So linear.
Okay, so this is going to be linear. Someone is saying non-linear, somebody is saying linear. Let's check that. Okay, so if x1t is the input of the system, what is going to be your output? Let's assume that to be y1t. Okay, and you will see that y1t will be equal to what? X1t times x1 of t minus 2. Similarly, if the x2t is the input, what is going to be your output? Y2t, and Y2t will be equal to x2 times t into x2 times t minus 2. Now if we give the system a1 x1t plus a2 x2 of t as input to this system, okay, and let me assume that this is equal to x dash of t, then let me assume output is y dash of t, and y dash of t will be equal to x dash of t into x dash of t minus 2. What is x dash of t? Is a1 x1 t plus a2 x2 t. This is x dash of t, isn't it? And this times a1 x1 of t minus 2 plus a2 x2 of t minus 2. And if you do this multiplication, you will clearly see that this will not be equal to a1 y1t plus a2 y2t. You can multiply here. If you want, I can do that, but it's going to take some time. You can see that you will be getting a1 square x1 t into x1 t minus 2, isn't it? a2 square x1 t x2 t into x2 t minus 2. So instead of a1 x1 t and x1t minus 2, you are getting a1 square, isn't it? So that's why this will not be equal to a1 y1t plus a2 y2t. So this system is non-linear. ये सिस्टम क्या है आपका? Non-linear है. Okay, so whenever you are multiplying two system, uh, uh, the result has to be kind of, you will have to check every time, but mostly it's going to be non-linear. And sometimes even if you multiply to non-linear system, there may be situation where you will get linear. Okay, so you always have to check in a situation like this. Okay, but mostly it's going to be non-linear. Now let me give you another problem here, and that is very much known, and this example says that output yt is equal to xt times cos n omega naught t. Okay, so you are multiplying your input with a function of time. So this here, I mean, इसको अलग फॉर्म में लिखना है तो ये ft हो जाएगा, राइट, वेयर ft इज फंक्शन ऑफ टाइम, नोन फंक्शन ऑफ टाइम. cos n ओमेगा नॉट t को आप प्लॉट कर सकते हैं, राइट. लेट n की जगह let me just write this 2 pi f naught t only. Okay, cos omega naught t only. Okay, just tell me whether this system will be linear or not. It's a very famous system, isn't it? आप लोगों ने ये सिस्टम पहले देखा है इससे पहले? Those who are in third year, have you seen this system? आप लोगों ने पहले सिस्टम देखा?
Modulating, sir.
It's
Is it modulation, sir?
yes, it is modulation only. Okay. So just tell me whether this amplitude modulation to be specific, and actually it is double sideband suppressed carrier DSB-SC modulation. So just tell me whether this will be linear or not. It's a very famous system.
Linear.
So it's going to be linear. Somebody is saying anyone else? Let's again check this. We'll have to verify every time. If x1t is the input to the system, what is going to be output? y1t, isn't it? And that will be equal to x1t times cos omega naught t, isn't it? And similarly, if the x2t is the input to the system, let me assume that output is y2t, and this y2t will be equal to x2t times cos omega naught t, isn't it? And if you give this system x dash t, which is equal to, let me just write a1 x1 t plus a2 h2t, okay, then your output will be equal to y dash t, and y dash t will be equal to what? X dash t times cos omega naught t. So if you expand this, what you are going to get? Your y dash t is going to be equal to a1 x1 t plus a2 x2 t, that is x dash t, and this is time cos omega naught t. Now if you multiply this, you will get a1 times x1 t cos omega naught t plus a2 times x2 t cos omega naught t. Okay, so you can see that this is clearly equal to a1 y1 t plus a2 y2 t. So this system is linear. क्या है system? Linear है. So based on just this example, you can see, you can tell me whether yt is equal to e to the power 3t times x of t minus 2 is linear or not. Whether this system is linear or not. Can you tell me based on this example?
Linear,
Sorry?
sir.
Linear, sir.
Linear.
It's going to be linear, right? Isn't it? Similarly, you can have like this e to the power, let's say, or let me just give another function here, log of 2t times x of 2t. Okay, so this is again going to be linear, isn't it? Why it is going to be linear? When you are multiplying a linear system with a known function of time that you already know, okay, e to the power 3t, you can easily plot it, log 2t, you can plot it, so you know this function. Okay, so in this case your system is going to be linear only. When you multiply by constant, let's say you have yt and yt, let me write this, 10 times x of 2t plus 3. Tell me whether this is going to be linear or not. ये linear होगा कि नहीं?
Yes, sir.
10 is also a constant which is a function of time, isn't it? It's only thing is that it is a constant. So this is again going to be linear. Okay, so based on this you can find out these many questions and all of them are going to be linear. Now let me just slightly change the problem. You have again example, your output y of t is equal to let's say x of 2t plus cos omega naught t. Again, I mean, instead of multiplying, now I am adding. Tell me whether this will be linear or not. I am adding a function of time to a linear system. Yt is equal to x of 2t is linear, isn't it? And you are adding a function of time, well-known function of time, cos omega naught t.
So non-linear.
It's going to be non-linear. Does everybody agrees that it's going to be non-linear? Okay, so you can easily prove that. Actually, it's not difficult. The only thing is that I will have to do a bit of work here. So let's say x1t is the input and output will be y1t, and what will be y1t will be equal to x1 of 2t plus cos omega naught t. Similarly, when x2t is the input and you have what is going to be y2t, and y2t will be what? x2t, x2 of 2t plus cos omega naught t. And let's say when your input is x dash of t, which is equal to a1 x1 t plus a2 of x2 of t, then your output, let me assume this to be y dash of t, then this is going to be equal to what? X dash of 2t plus cos omega naught t, isn't it? And what is x dash of 2t? It will be a1 x1 of 2t plus a2 x2 of 2t, isn't it? t की जगह 2t लिख देना है बस, and plus cos omega naught t, sorry. So is y dash t is equal to a1 y1 t plus a2 y2 t. A1 y1 t plus a2 y2 t is going to be what?
No, sir,
A1
it is not equal.
x1 2t plus a1 cos omega naught t, isn't it? And then you will have a2 h2 of 2t plus a2 cos omega naught t. And here you can see that you have a1 x1 t plus a2 x2 t, but after that you have only cos omega naught t. Here you are getting a1 cos omega naught t plus a2 cos omega naught t. So y dash t is not equal to this, isn't it? It means the system is non-linear. So whenever you are adding a function of time, okay, that system will become non-linear. And just based on this only, you can now conclude about these problems. Let me just write this. Yt is equal to e to the power 2t cos omega naught t x of 2t plus 3 and plus, let me just write this here, 3. Tell me whether this system will be linear or not. It's going to be non-linear. Why? Again, you see, you break this. Yt is equal to x of 2t plus 3 will be linear. If you multiply with e to the power 2t, which is a known function of time, or and cos omega naught t, e to the power 2t cos omega naught t is a known function of time. So multiplying by this is not going to make the system linear. But when you add something, add a constant or add a function of time, then it will become non-linear. Is this clear? So you will be seeing very complicated kind of thing, okay? But you will have to kind of break that down and you will easily see the patterns that, okay, whether it's going to be linear or non-linear, isn't it? So you have x of uh, t plus 3. This is also going to be non-linear, isn't it? So both of these are non-linear. Is that clear to everyone? Is it clear to everyone?
Yes, sir.
Okay. Now let me give you some very simple problem which you can easily see. You have yt and yt is equal to 2 to the power x of t. Tell me whether this system will be linear or not. So let me give you some examples here that you can try on your own. Yt is equal to xt or yt is equal to signum function. So signum signum of xt, and then yt is equal to, let me just write this, uh, complex conjugate of xt. And so these are all the system, different system. Yt is equal to real of xt, yt is equal to let me just write this median. Okay, median रहने दो. Anyway, median of जाने दो. Let's forget about this one. So you try to do this and all of them can be solved by, ओके कोई नहीं, आप सबको ट्राई करो और देखो कौन कौन सा लीनियर है, कौन कौन सा लीनियर नहीं है. ओके and then after that let me give you another set of problems here, that is yt is equal to d upon dt xt, differentiation of xt, yt is equal to integration. So integration here is a function of time minus infinity to t x of tau d tau. Okay, tell me whether these two are linear or not. So total I have given you 6 problem, right? Have you all noted them down? आप लोग नोट डाउन कर लीजिए इसको. Sorry?
Sir, can you please show sixth one?
Sixth one is this one. Yt equal to d upon
Okay, sir,
dt xt and minus infinity to t x of tau d tau. So this is called differentiation का उल्टा ये ऑपरेशन होता है. Okay? Differentiation का उल्टा ऑपरेशन क्या होता है? Minus infinity to t. Is this clear to everyone? So indefinite integration की जगह हम लोग ये इंटीग्रेशन यूज करते हैं डिफरेंशिएशन का अपोजिट करके. एंड you can verify that this is exactly opposite.
Sir,
क्योंकि
number 5
डेफिनेट
are linear.
नंबर 5 d upon d x t dt d upon
Derivative
dt
and
x t.
integration, sir.
Integration and differentiation both are linear operation. You
Yes,
can
sir.
remember them. Differentiation and integration are going to be linear operation. Just think of it like this. I mean, they are basically differentiation is difference, isn't it? You are subtracting, and integration means you are adding. So difference निकालना और add करना. अभी आप लोगों ने देखा एक्स टी एक्स ऑफ टू टी एड किया, हमने क्या मिला? लीनियर कॉम्बिनेशन. मैंने बोला था लीनियर कॉम्बिनेशन अगर लीनियर सिस्टम का है तो वो लीनियर ही रहता है. सो बोथ ऑफ देम आर गोइंग टू बी लीनियर. Now you identify these problems and you can get quite a few of them. You have to practice as many questions as you can, okay, in order to understand this. Okay, so you can solve all these problems on your own. Now let's move on to the next topic, that is next classification of the system. So now we are going to classify system based on whether its its relationship is changing with respect to time only. So something called time invariant and time variant system. Okay. So the next topic is time, and you are going to get good as many problem as you solve. Okay, it's not something that you will be getting in one day. But let me just tell you one more thing here. There is a book by Signal System and Transform by by Philip, I think. Okay, and it's at the end of its second unit or second chapter, there are about 40 questions. Okay, so if you solve all those, okay, and out of those 40 questions only about 10-15 are based on system classification. So if you solve all those and conceptually solve them, if you really understand those problems, then no matter what is the question that is asked in gate, you can be confident that you will be able to solve them. Is that clear? So we will try to get that book from the library and आपको फोटो निकाल के मैं दे दूंगा वो, ठीक है, ताकि आप उतना प्रॉब्लम ट्राई कर लें. ओके.
सर एक बार
So
आप
now
नाम बता सकते हैं क्या उसका बुक का?
सिग्नल सिस्टम एंड ट्रांसफॉर्म करके बुक का नाम है. मैं दिखाता हूँ आपको, यहाँ पे मिल जाएगा. इट्स अ गुड बुक स्पेशली फॉर द फर्स्ट यूनिट. लेट मी जस्ट सिग्नल सिस्टम एंड ट्रांसफॉर्म, सिग्नल Okay, ये book नहीं, ये नहीं है भाई, Phillips. Okay, इमेज देखते हैं. सिग्नल सिस्टम एंड ट्रांसफॉर्म, आई थिंक ये बुक है चार्ल्स फिलिप्स. ओके, सो यू कैन सी दैट है. काफ़ी में ये लाइब्रेरी में भी बहुत है. अबाउट 50 some copies are there in the libraries, our library only. Okay, and it's a very good book, especially for solving problem. Okay, I mean, theoretically they have kind of gone over the things pretty quickly. Okay, but अगर आप वो उसका थ्योरी को थोड़ा सा डिस्कार्ड कर दें तो प्रॉब्लम्स आर रियली रियली गुड. ओके, स्पेशली फॉर द फर्स्ट फ्यू यूनिट्स. ओके, किधर गया. So now we are going to discuss about time invariant and variant system and time variant system. So
Sumit, I have shared the photo of that book in chat box.
okay, okay. So all of you can check that, and this is
So you can
also
see
called
the
shift invariant and variant.
Sumit,
Variant. हाँ बोलिए. हाँ बोलो.
I have
हाँ
shared
बोलो.
that book photo in the chat box.
Okay, let me just see that. This is the book. Signal System and Transform by Charles Philip. I mean, I don't remember the rest of the name, but Philip. It's a very good book if you want to solve problem. It's available in library as well, so you can see that. And इसका जो है second chapter का हम लोग फोटो कॉपी दे देंगे या सोल्व करने के लिए आप लोग. ठीक है.
Yes.
So let's move on to this shift invariant, or you can call this shift variant system. Okay, so uh, a system is called, so let me just write this definition here. A system is called time invariant if its input output dash output, let me write input output characteristic doesn't does not change with time. Okay, a system is called time invariant if its input output characteristics doesn't change with time. Okay, and what is the meaning of this if I translate this loosely to let me just try to do this here. So let's say this is our system. Okay, and it has some input, and because of that input we are getting some output. So this is input and this is output. Okay, and let's say the input of the system is something like this. Let's say you are giving this rectangle. Okay, let me just draw this a bit properly using some different color. So let's say that the input of the system that we are giving here is like this: 0 to 1. Let's say this value is 1 here, and from 0 to 1 you are giving this input, and because of that you are getting a output. Let's say output is kind of delayed a bit and something like this. So it's, let's say, 1 to 2, and this value is again 1. Okay, So if you are delaying your input, let's say your input is starting from 0 to 1, and now you are giving a delayed input, that is, let me give it to be like this, that your input is kind of delayed, and it's now starting from 1 and going to all the way up to 2. So it's starting from 1 and going all the way up to 2. So it's kind of delayed by 1 unit here. Then your output also must be delayed by the same amount. Okay, तो output 1 से start हो रहा था, तो अभी कहाँ से start होगा? It's going to start at 2 and end at 3. Okay, so if input is delayed, output must be delayed by the same amount. Okay, and then your system is going to be called shift invariant. Okay, so mathematically let me write it like this, that if xt is input to the system and due to xt your output is yt, then for t naught, where t naught is just a real number, okay, x of t minus t naught must produce output y of t minus t naught. इज दैट क्लियर? आपने इनपुट को डिले किया तो आउटपुट भी डिले होना चाहिए, तभी तो इसका मतलब है उसका कैरेक्टरिस्टिक चेंज नहीं हुआ। टाइम के साथ आपने टाइम चेंज कर दिया तो भी आपका आउटपुट सेम है। आर यू गेटिंग माइट? सेम का मतलब क्या है? जितना अमाउंट से आपने इनपुट को डिले किया उतना ही अमाउंट से आपका आउटपुट भी डिले हुआ। इज दैट क्लियर टू एवरीवन? जैसे आप लोग कोई रिकॉर्ड प्ले कर रहे हो, आप कोई भी म्यूजिक गाना सुन रहे हो, ठीक है, गाना सुन रहे हो ना आप उसको अभी सुनो 12 बजे, आप उसको 6:06 पे आप सुन रहे हैं, ठीक है, या बंद कर दो, आप 1 घंटा बाद सुनो। आपने अपना इनपुट क्या किया? 1 घंटे से डिले किया, तो सॉन्ग भी सेम प्ले होगा ना कि कोई दूसरा सॉन्ग प्ले होने लगेगा? आपने जो भी सिस्टम में रखा है गाना वही प्ले होगा। आर यू गेटिंग माय पॉइंट? सो डिले जितना आपने इंट्रोड्यूस किया उतना ही डिले से आपका आउटपुट भी डिलेड होना चाहिए। इनपुट जितने अमाउंट से डिले हुआ उतना ही अमाउंट से आउटपुट भी डिले होना चाहिए। दिस इज व्हाट वी मीन दैट सिस्टम का जो, तभी तो हम बोल सकते हैं अगर उसका आज आपने एक सिस्टम डिजाइन किया वो 10 दिन बाद भी काम करेगा, तभी तो काम करेगा जब उसका सेम कैरेक्टरिस्टिक रहे। और उसका कैरेक्टरिस्टिक चेंज हो जाएगा तो वो कुछ का कुछ देने लग जाएगा। बात समझ में आ रहा? आज आपने जो बैटरी डिजाइन की, आज अगर वो 10 वोल्ट दे रहा है तो हम क्या चाहते हैं आज के 20 दिन बाद यूज करें तो भी वो 10 ही वोल्ट दे। Isn't it? So this is what is called as shift invariant system or time invariant system. And if system is not satisfying this, then it will be called time variant system. Okay, so let me do this graphically. Okay, graphically ये इसका एक डायग्राम बना के आप लोग को बताता हूँ मैं।
सी ये कैसा है कि अगर आपने एक नेटवर्क लिया, राइट, नेटवर्क में रजिस्टर्स हैं, तो today I give some input to this network which is like a system for me, and some voltage like 2 volt, and I am measuring some voltage across any register. So today I will do that experiment with the same input voltage with the same circuit, and next day also I am going to do the same experiment with that circuit. The output across that particular resistor should not change, right? If it is not changing, then I will say it's a time invariant. Or it is like, you can think like when you see the cricket match, so your YouTube when you see some live cricket match on satellite TV or normal TV, then you expect some delay, right? But you get the same information. So delay is acceptable, right, when you are transmitting something or doing something. But to do the analysis more easily, or to have analysis easier, system should be time invariant. It is very difficult to analyze the time variant system.
Okay, so with the help of this picture, you can actually find out whether your system is time invariant or not. So what we are going to do, let me just talk about the top one first. we are taking input xt and then we are introducing a delay of t naught. Okay, कितना डिले कर रहे हैं हम, t naught अमाउंट का डिले कर रहे हैं. तो xt को डिले करोगे तो आपको क्या मिलेगा? What is it that you will be getting? x of t minus t naught, isn't it? आपने इनपुट को डिले किया तो क्या मिलेगा? इनपुट xt है, xt को डिले किया x of t minus t naught, isn't it? And then you applied the system t. Okay, so you will be getting y of the delayed input, and let me just write this, that this is t of x of t minus t naught. Okay, and here what we are doing, we are introducing our system first. तो xt में आपने सिस्टम लगाया तो आपको आउटपुट मिलेगा. आउटपुट क्या है? y of t. एंड yt में आपने फिर t naught का डिले किया तो क्या मिला? y of t minus t naught. So you have to compute y of t minus t naught like this and y of t comma t naught like this, and if they are equal then system is time invariant. Okay, and otherwise they are going to be time variant. Is this clear to everyone? So can you note down this picture so that you should know how to follow these procedures? Okay, and let's solve some problem, and it will be very easy actually. So let's start with the very simple
Sir, will you
function.
please
Will
explain the diagram again?
okay, just a minute. What we are going to do, हमने इनपुट लिया xt, इसमें पहले डिले करके x of t minus t naught निकालेंगे, ठीक है? और x of t minus t naught डिलेड इनपुट की वजह से हम अपना आउटपुट निकालेंगे सिस्टम लगा के, ठीक है? So on top of this, let me highlight this. Here we are computing output due to delayed input. यहाँ पे क्या कर रहे हैं हम लोग? आउटपुट निकाल रहे हैं ड्यू टू डिलेड इनपुट. इस इनपुट x of t minus t naught की वजह से निकाल रहे हैं. Is this clear? And after that, here on the bottom what we are doing, हम अपने आउटपुट को ही डिले कर रहे हैं. xt का आउटपुट क्या मिला आपने? yt, और yt को हमने डिले किया तो y of t comma t minus t naught निकाल रहे हैं. So this y of t minus t naught must be equal to y of t comma t naught. Then you will say that your system is time invariant. Is that clear? यहाँ पे क्या बोल रहा है?
Yes, sir.
x of t minus t naught, अगर आपने जो भी डिले किया उसकी वजह से आपको आउटपुट क्या मिलना चाहिए? y of t comma t naught. Is this clear? अगर ये नहीं मिल रहा है इसका मतलब क्या है कि आपका सिस्टम टाइम वेरिएंट है. Let's see one or two of problem and then you will understand how this is actually working. So let's say that our output system is this only, yt is equal to x of t. Okay, and tell me whether this system is linear or not. So this system is time invariant or not. So let me draw the picture again here. Let me solve this for you. So okay, so this is our xt input, and first what we are doing, we are introducing delay here. So due to delay, what we will be getting? X of t minus t naught, isn't it? And then we are applying our system, and system क्या बोल रहा है हमारा? System क्या बता रहा है आपको? ये system क्या signify कर रहा है? Can anybody tell me what this system is signifying? Output is exactly equal to what? Input, isn't it? ये system क्या बोल रहा है आपको? Output is exactly equal to input, isn't it?
Yes, sir.
So यहाँ पे आपको आउटपुट जो है y of t comma t naught किसके बराबर मिलेगा? Exactly इनपुट के बराबर. इनपुट क्या है? x of t minus t naught. And then what we are doing, we are applying system here. So system में अप्लाई किया तो आपको क्या मिला? yt और yt में क्या कर रहे हैं हम लोग, डिले कर रहे हैं टी नॉट अमाउंट से, राइट। तो आपको क्या मिल जाएगा, y ऑफ टी माइनस टी नॉट। और y ऑफ टी बराबर किसके है, xt के बराबर ही है, राइट। तो y ऑफ टी कोमा टी नॉट किसके बराबर होगा, x ऑफ टी माइनस टी नॉट के बराबर। So you can see that these two are equal, isn't it? Both of them are equal. So system is time invariant. System क्या है, time invariant है, and it's a very simple system. So it's satisfying all yt equal to xt, जितने भी property हैं सब satisfy करता है. So you don't have to worry about that. This is something that I just want to solve, and then we will move on to the next one. Now the problem, second question here is that yt is equal to, let me just write this one here, e to the power 2t times x of t. Tell me whether this system is time invariant or not. This was linear, isn't it? This system was linear, isn't it? e to the power 2t की जगह आप लोगों ने जो सिस्टम देखा है वही कर देता हूं मैं. Let me make this dsb sc only. Okay, xt time cos omega naught t. Okay, it's the same thing, same difference, doesn't matter, but so that you understand about this system, this is the system that you have studied in quite detail. So yt is equal to st time cos omega naught t. Tell me whether this system is time invariant or variant.
सर वेरिएंट.
That will be time variant. सबने निकाला यही कि किसी का कुछ और आ रहा है?
सर वेरिएंट.
Time variant है. Let's check that. Okay, with the help of the diagram. I'm a bit. Okay, रुको मुझे ये line tool लेने दो. That will be much better. Okay, and from here. Okay, so I have drawn the diagram. Let's just start with. So xt will be input here, and यहाँ पे क्या कर रहे हैं हम लोग? पहले हम लोग we will introduce delay first, right? So delay first किया हमने तो t नॉट कितना क्या मिलेगा हमें यहाँ पे? x of t minus t नॉट, right? Is that clear? और यहाँ पे हम लोग सिस्टम अप्लाई कर रहे हैं t. So what is सिस्टम की वजह से हमें आउटपुट क्या मिलेगा बताइए? सिस्टम क्या कर रहा है? इनपुट में cos ओमेगा नॉट t से मल्टीप्लाई कर रहा है, राइट? सो आई विल बी गेटिंग हियर xt टाइम्स व्हाट, cos ओमेगा नॉट t. इज दिस क्लियर टू एवरीवन? नाउ हियर वी आर अप्लाइंग आवर सिस्टम t. अब यहाँ पे आउटपुट क्या मिलेगा? y ऑफ t कोमा t नॉट. और मुझे बताओ y ऑफ t कोमा t नॉट कितने क्या होगा?
x of t minus t naught into cos of omega 0 in bracket t minus t naught.
यहीं पे आप गलत हो रहे हैं. सिस्टम क्या है? इनपुट में क्या मल्टीप्लाई कर रहा है? इनपुट में किससे मल्टीप्लाई कर रहे हो आप? cos ओमेगा नॉट t से. बात समझ में आ रहा है? जो भी इनपुट आ रहा है उसमें किससे मल्टीप्लाई कर रहे हो? cos ओमेगा नॉट t से. यहाँ पे इनपुट क्या है, एक्स ऑफ टी माइनस टी नॉट, तो यहाँ पे क्या मिलेगा आपको बताओ, इनपुट में किससे मल्टीप्लाई करोगे, कॉस ओमेगा नॉट टी से करोगे कि ओमेगा नॉट टी माइनस टी नॉट से करोगे,
cos ओमेगा नॉट टी।
कॉस ओमेगा नॉट टी से। हमारा सिस्टम क्या कर रहा है, इनपुट कुछ भी हो उसमें कॉस ओमेगा नॉट टी से मल्टीप्लाई कर रहा है, राइट। तो इनपुट हमारा क्या है, एक्स ऑफ टी माइनस टी नॉट, तो इसमें मल्टीप्लाई कर दिया आपने, तो यू विल गेट एक्स ऑफ टी माइनस टी नॉट इनटू कॉस ओमेगा नॉट टी। Okay, is this clear? Now here we are applying delay of t naught, so t will be replaced by t minus t naught, right? So we will be getting y of t minus t naught, and that will be equal to t की जगह t minus t naught लिख देना है, तो what I will be getting, x of t minus t naught and times cos of omega under bracket t minus t naught. Now tell me whether these two are equal. Are they equal here?
No, sir.
No, right? So it means this is a time variant system. ये क्या है आपका, टाइम वेरिएंट सिस्टम है. It's a linear system but it's time variant. Okay, is that clear to everyone? Now let's, it's a very famous system, so that's why you should know about this. And next system that I am going to take is again a very famous system, that is delay. Okay, तो yt is equal to हम लोग लेंगे x of t minus let's say 2, and tell me whether this system is uh, time invariant or variant.
सर इनवेरिएंट।
It will be time invariant. Anyone else?
Invariant, sir.
कंफर्म हो, इनवेरिएंट होगा, वेरिएंट होगा. ओके, लेट्स सी दैट. सो मैं ऊपर से कॉपी करता हूँ इसको, ड्रॉ कौन बार बार करे. Okay, so let me just copy this part here from here to here. Control C, Control V. Okay. And मैं बाकी सबको रिमूव कर देता हूँ. So xt will let me just, ये ठीक है, यहाँ भी ठीक है, ये वैल्यू चेंज हो जाएगा, xt यहाँ पे भी चेंज हो जाएगा, ये वैल्यू भी चेंज. Okay. So now let's look at this. So यहाँ पे क्या मिलेगा, y ऑफ टी कोमा टी नॉट, x ऑफ टी माइनस टी नॉट से क्या कर रहा है, आउटपुट क्या कर रहा है, इनपुट जो भी हो उसमें डिले कर रहा है 2 का, राइट. यही कर रहा है ना, व्हाट इज योर आउटपुट. सिस्टम लगाने के बाद क्या हो रहा, इनपुट को डिले कर रहा है, तो यहाँ पे एक्स टी माइनस टी नॉट ऑलरेडी है, तो यहाँ पे क्या मिलेगा, एक्स टी माइनस टू एंड देन माइनस टी नॉट, टी की जगह आपने टी माइनस टी टू लिख दिया. ये क्या कर रहा है, एक्स टी इनपुट है तो एक्स टी की जगह टी माइनस टू कर रहा है, तो यही वही कर दिया हमने. यहाँ पे क्या मिलेगा, वाई टी इक्वल टू एक्स ऑफ टी माइनस टू एंड देन आपने डिले किया टी नॉट से, तो टी को रिप्लेस किया टी माइनस टी नॉट से, राइट. तो यहाँ पे क्या मिलेगा आपको, एक्स ऑफ टी माइनस टी नॉट एंड माइनस टू ऑलरेडी है ये है. तो इज आर दीज टू इक्वल.
Yes,
हेलो.
sir.
So it means it is a time invariant system. So delay is time invariant. Okay, delay वाला जो system है वो क्या है, time invariant है. It should be clear to you. Is this clear? And let's just for the sake of completion look at this system. So the new system is yt is equal to scaled of xt, so x of 2t. Tell me whether this system is time invariant or variant.
time value.
It will be time variant.
Yes.
Let's just see this again. I'm just copying this here. And let me just remove this one here and this here. Okay, and this here as well. Okay, so just tell me what you will be getting here as y of t comma t naught. क्या मिलेगा आपको बता सकते हैं यहाँ पे what will be y of t comma t naught, t minus t naught.
Uh, x of 2 times t minus t naught.
So you will be getting, देखो हम क्या कर रहे हैं, t को रिप्लेस कर रहे हैं 2t से. किससे रिप्लेस कर रहे हैं, xt इनपुट था, आउटपुट क्या मिला, x of 2t, यानी t को आपने रिप्लेस किया 2t से, राइट. इज दैट क्लियर. सो हम यहाँ पे क्या करेंगे, t को रिप्लेस कर देंगे 2t से, तो हमारा क्या था x of t माइनस टी नॉट. अभी t को रिप्लेस कर दिया 2t से, तो 2t माइनस टी नॉट मिल गया. ओके, व्हाट यू विल बी गेटिंग हियर, यू विल बी गेटिंग x of 2t, राइट. और यहाँ पे आपको क्या करना है, डिले करना है. डिले मतलब t की जगह t माइनस टी नॉट लिखना है. तो t की जगह t माइनस टी नॉट लिखोगे यहाँ पे, तो क्या मिलेगा 2t minus t naught, and that will be equal to what, x of 2t minus 2t naught, right. Tell me whether these two are equal or not. Are these two equal?
No, sir.
So this means this system is time variant. Time variant system. Okay. So I'm just going to end this session today here. Just one question as homework I will give you, and then you can try that at home. So we have two questions. Y is equal to cos x of t, and एक दो और दे देता हूँ, y is equal to x square t. Okay, and the third question is like this, yt is equal to cos xt plus x of 0. So these three questions, please solve them. Okay, try to solve them and we will discuss them. अगर आप लोग को confusion रहा तो we will discuss them in the next session. Is this okay?
Yes, sir.
Okay, so try to solve as many problem as you can. जितना भी प्रैक्टिस रहेगा आपको, आप बहुत सारे कंफ्यूजन ऑलरेडी हो जाएगा एग्जाम में जाने से पहले. सो दैट इज ऑलवेज बेटर दैट कंफ्यूजन एग्जाम से पहले हो तो ज़्यादा अच्छा है, ताकि आप लोग एग्जाम में वो गलती नहीं करें. Okay, so I hope that all of you have noted it down. I'm going to end this session now.
Thank you, sir.